Cool. So let's just go through these in order. If you understand all these proofs, then you should be able to. If you understand all of these questions, then you should be able to handle the quiz pretty easily. Um, so prove by induction that 7 to the n minus 1. So 7 to the n minus 1 is divisible by 6. So what do people think the first step's going to be? It's induction, so
Solve the base case.
exactly. What do you think we want the base case to be?
1.
Yeah, 1 or 0 works, but we'll go with n equals 1. Then base case. We get 7 to the 1 minus 1 is equal to 6, which is in fact divisible by 6. So now we have to move on to the inductive hypothesis. And so for the inductive hypothesis, we assume that 7 to the n minus 1 is divisible by 6. And we want to show 7 to the n plus 1 minus 1 is divisible by 6. So in order to jump from 7 to the n minus 1 to 7 to the n plus 1, let's just multiply everything by 7. That's not going to give us exactly what we want, but it's going to get us kind of close. So that's going to give us equal to 7, so 7n plus 1 minus 7, right? So what are we going to do from here? What do we know about this?
The inductive hypothesis.
Well, we're trying to do the inductive hypothesis right now.
Oh.
So we know that this guy right here is divisible by 6, right? So what does that tell us about this guy?
Should be divisible by 6 as well.
Yes, exactly. So this is also divisible by 6. Because one of its factors is. Namely, 7 to the n minus 1 is. So I have 7 n plus 1 minus 7. And I want 7 n plus 1 plus minus 1. How do you think I'm going to get there? I'm just going to subtract 6, right? That's the difference between them. So therefore, 7n plus 1 minus 7 is divisible by 6. Therefore, 7 to the n plus 1 minus 7 plus 6 is divisible by equals 7 to the n is divisible by 6. Does that make sense? Does anyone not understand that? Cool. So what is the contrapositive of if I study, I can skydive? So does anyone remember the structure of contrapositives?
If I can't study, I can skydive.
If
If I don't study, I can't skydive, sorry.
no, that's the converse.
Oh,
So we have P implies Q, and the structure of the contrapositive is not Q implies not P. So this guy right here is Q. This guy right here is P. I didn't put a then there, but you can imagine that there's a then there. It's the same meaning. So if I were to switch this around, then if I can't skydive, then I don't study. And usually these things have seem like they've got more of a relationship between them, but I pick this because both it's more fun and just to bring home the point that material implication, that the first half doesn't have to seem like it has anything to do with the second half. It's just about the structure of it. So what is 5 choose 1? Someone want to tell me the factorial definition for this? Right? Which is just 5 factorial divided by 4 factorial is equal to 5. 5 choose 2. That's going to be equal to 5 factorial divided by 2 factorial times 5 minus 2 factorial, which we normally write as 3 factorial. So that's going to be equal to 5 times 4 divided by 2 is going to be equal to 10. And if I do 5 choose 3, that's going to be equal to 5 factorial divided by 3 factorial, 2 factorial. 5 factorial. So that's going to be, again, it's just going to be the same thing. This time the 2 factorial comes from 5 minus 3, and the 3 comes from this right here. 5 times 4 divided by 2, 10. Cool. And 5 choose 4 is equal to 5. 5 choose 5 is going to be equal to 1. So what do people think I'm going to use to do this? Anyone?
Could you scroll back up? Can I see that again? Sorry. Just wanna. Thank you.
Do you have any questions with it, or are you just trying to?
I was just looking at it. Just wanted to make sure everything. Okay. Thank you.
No problem. So any guesses here? This is the binomial expansion, and we can use something like the Pascal's triangle if we want to save us some time. 2, 1, and then we get 1, 3, 3, 1, and that is the correct. Sorry about that. This is the relevant line right here. So if we were to do this out, we would get 2x to the 4 times 3y to the 0. plus 3 times 2x cubed times 3y to the 1 plus, oh, sorry, this should have been 3. This should have been squared. Plus 3 2x to the 1 3y squared plus 3y to the third, and we also get that 2x to the 0, which is just 1, and we also get the 1 from the coefficients here. So if this isn't ringing bell, look back at the Pascal's triangle and binomial coefficient stuff. So then I look at this guy, and that's going to be 8x cubed plus this guy is going to be, this will be 4 times 9. So that's 36x squared y plus this will be 54x y squared. And sorry that my x's and my y's look basically the same, plus 27y cubed. Does that make sense? Cool.
Yep.
Yeah, no objections? Okay, anagrams. So does anyone remember what the rule is for anagrams? So I'm going to see how many letters there are in this word. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8. Good, that's what I thought. So we've got 8 factorial to start off with. But then, like, that's how many different ways I can put the first letter and the second letter and the third letter and the fourth up to the 8th letter. I can rearrange them in 8 factorial ways. But guess what? E, I don't care if I have 2 different E's. Or I don't care if I switch 2 of the E's. So if any of those E's are switched among each other, it's the same thing. So I divide by 3 factorial. Same thing with those R's. So that gives me this, and then you can think of, if you really want, you can think that this guy is a 1 factorial, and this guy is a 1 factorial, and that guy is a 1 factorial, but we don't have to write them out. So this is the answer that we would get, and then just plug in the factorials. I don't have a calculator near me, so I'm not going to bother. This guy is also going to be 8 factorial, coincidentally. You know what? I'm going to change this so that it is actually spelled correctly, so that I get a different answer, because otherwise it would have been the exact same thing. So now I'm dealing with 7 factorial, and then I have 1, 2, 3 A's, and then every other letter is unique, so it becomes 3 factorial, divided by 3 factorial. So that's equal to 7 times 6 times 5 times 4, which is, I think, 840, which would make this guy 420. So how many ways can you pair up 6 people? Does this question look familiar to anyone? It was one of the examples that was given to you guys. So I'm actually just going to say, look up the video that has the formula. Or 2n. That was one of the ones that I did. So prove no integer is both odd and even. So what method do you think we should use for this? Any intuition? Anyone?
Contradiction.
Exactly. Assume we have z in z such that it is both odd and even. What is the definition of even that we have? Z is equal to 2k for some k. In the integers. This is and uh, 2j plus 1. The integers. So therefore 2k is equal to 2j plus 1. But then we can divide both sides by 2. And this implies that k is equal to j plus 1/2. But this is a contradiction. Because k and j cannot both be integers. They differ by 1/2. Integers have to differ by a whole number value. How many ways can a raffle assign its first, second, and third prizes if there are 6 participants? This is the ordered subsets section. Does anyone want to hazard a guess what it'll be? Nope, nobody. Well, for first prize, 6 options. But first option is gone for my second prize. So second prize, I have 5 options. And third prize, those first 2 are gone, so I'm down to 4 options. So I have 6 times 5 times 4. You can also do this as the branching tree possibility, branching trees of possibilities if you want. But this guy right here is good enough, so gives us 120. So prove that the square of an integer has the same parity. Does anyone know what the parity means? It just means odd or even. So what method do people think I'm going to use for this? Anyone?
Proof by cases.
Exactly. So we will prove this with our cases being n is even and n is odd. So case 1, n is even. Therefore, n equals 2k. Therefore, n squared is equal to 4k squared, right? And that's equal to 2 times 2k squared. So we'll just call this guy J, and therefore, if n is even, n squared is even, and they have the same parity. Let's start this farther over so I have more room to work here. And the other case, n is odd. Therefore, n is equal to 2k plus 1. Therefore, n squared is equal to, we get 4k squared plus 4k plus 1. So that is equal to 2 times 2k squared plus 2k plus 1, and we'll call this guy J. Therefore, n squared is odd, and n squared have the same parity. So in both our cases, I'll just both our cases. So does anyone have any questions on anything that I've done here? Does this make sense to people? Basically, all of the questions, I think there was one question that I didn't have something that's very similar here. There's 9 questions on the quiz, so you can count them up and see. But it's basically I've got one covering the contrapositive, and then one covering contradiction, one proof by contradiction, one proof by induction, one proof by cases, blah, 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 and then a few of the different counting techniques. So nobody has any questions? Nobody objects to me posting this video online? No? Cool. Then have a good day.